Hello everyone, today we'll be looking at the quick solutions to the chemistry section of All India AIATS Test Series JEE Advanced 2020 Test 1A Paper 1 Code A and B. So let's start with the first section. So students, the first section contains 6 questions. Each question has 4 options, out of which one or more than one option may be correct. Okay, so let's start with the first question in this section. Question number 19. It says, a certain crystalline compound P can be prepared by fusing calcium metal with boron. Okay, compound P has density 2 gram per centimeter cube, and the unit cell of P is a cube with edge length 464 picometers. If calcium metal is present only at corners of cube, but boron is present in interstitial side of crystal, then the empirical formula of the crystal is. So the Avogadro number has been given to us, the atomic masses of calcium and boron have been given to us, and it is given to us that the cube root of 100 is equal to 4.64. Okay. Students, if we talk about the lattice which is given to us, there are calcium metals present at only one corner. Okay. So the effective number of calcium atoms present in one unit cell is going to be 1. So Ca1. Okay. The number of boron we have to find out. So let us assume that the crystal is CaBN. Okay. So if we talk about the density data which is given to us, we have D is equal to Z into the molar mass upon Na upon A cube. Okay. So the density given to us is 2 gram per centimeter cube. So 2 will be equal to Z. We can find the value of Z. The value of Z will be equal to 1. The M has to be found out. Avogadro's number is 6 into 10 to the power 23. And if you talk about the value of A cube, so the density data is given to us in centimeter cube, so the value of A has to be put in centimeters. So A given to us is 464 picometers. So 464 picometers, when it is converted into centimeters, we have 4.64 into 10 to the power minus 8 centimeters. Okay, so we can directly cube this value. So we have 4.64 into 10 to the power minus 8 whole cube. Okay, so on simplification, we get the value of M equal to 12 into 10 to the power 23 into 4.64 cube. So 4.64 cube, we can clearly see that it will come out to be equal to 100 from the data given in the question. So this is 100 into 10 to the power minus 24. So upon simplification, we can clearly see that the value of M is equal to 120. So students, if we talk about the molar mass, so we have 1 calcium and we have N boron atoms. So 40 plus 10N should be equal to 120, which on solving gives us a value of N equal to 8. So students, the formula for the solid is CaB8, which is given correctly in the C option. So for this question, we have to mark the correct answer as option C. Let us look at the next question now. Question number 20. Consider the following statements. So we've been given 4 statements and we have to comment on the correct statements. So S1, it says, Frenkel defect does not change the density of the solid. This is the correct statement, students. Frenkel defect is a dislocation defect in which an atom is dislocated from the lattice point and is present inside the interstitial side of the solid. So statement 2 is also correct. If we talk about the third statement now, intrinsic defects increase the conductance of the solid. This is correct, students. The defects lead to an increase in the conductance of the solid. If we talk about the fourth statement now, the Schottky defect decreases the density of the substance. So this is also correct. In the Schottky defect, the ion pairs are missing from the solid, which will lead to a decrease in the density. So all 4 of these statements are correct. And if we look at the options which are given to us, we can clearly see that all of these options have to be marked as correct. So A, B, C and D. All of them have to be marked as the correct answer for question number 20. Let us look at the next question now. Question number 21. 2 solids P and Q have the following specifications. So the molar mass have been given to us. The density data, we can clearly see that both of these density values are D1, which means that they have the same densities. Okay, the edge length are X1 and X2, and it is given to us that the solid P has a body-centered cubic structure, which means that the rank of this solid is equal to 2. If we talk about the solid Q, it is given to us that Q has a face-centered cubic structure, which means that the rank of the face-centered cubic is equal to 4. So using the density data, we can find a relation between the M1, M2, X1, X2. Okay, so it is given to us that both have the same density. So D of P is equal to D of Q. So upon writing the expression for density, we have 2 into M1 upon Na upon X1 cube shall be equal to 4 into M2 upon Na upon X2 cube. Okay. So the Na and Na will cancel out each other, and this 2 and 4 will cancel 2 times. So we can clearly see that M1 by X1 cube is equal to 2 times M2 upon X2 cube. Okay. Let us look at the statements given to us now. Option A, it says if X1 equal to X2, then M1 must be equal to M2. So if we talk about the A option, students, if X1 is equal to X2, then M1 will be equal to 2 times the value of M2. So the A option is incorrect. If we talk about the B option now, it says that if X1 equal to X2, then M1 must be equal to 2M2. So we can clearly see that the option B is correct. So out of option A and option B, only the option B is correct. If we talk about option C and D, so in option C and D, the examiner talks about M1 and M2 being equal, and then he is interested in the relationship between the X2 and X1. So if we put the value of M1 equal to M2, we're going to have X2 cube is equal to 2 times X1 cube, which means that X2 should be greater than X1. If you look at the options which are given to us, option C, it says if M1 equal to M2, then X2 must be greater than X1. This is correct, students. If you talk about the D statement now, if M1 equal to M2, then X2 must be less than X1. So this is incorrect, students. In option C, we had already seen that X2 must be greater than X1 for this given condition of M1 and M2 being equal. Okay. So students, if we talk about the answers which we have to mark for this question, we can clearly see that the answer to question number 21 is option B and option C. Let us look at the next question now. Question number 22. Consider the following information about the given aqueous solutions. So we've been given 4 solutions. The freezing point and the boiling point have been labeled, and the examiner seems to be interested in the greatest freezing and the boiling point are respectively. Okay. So students, all of these solutions are aqueous solutions. So the value of Kf and Kb will be same for all of them. Okay. So all that is left now is to figure out the value of the molality. So we know that delta Tf is equal to Kf into M. And if you talk about delta Tb, it is equal to Kb into M. We have to include the want-off factor wherever relevant. Okay. So the first step is to find out the value of the molality. So we've been given weight by weight percentage in the first 3 options, whereas in the 4th option, directly the value of molality has been given to us. Okay. So we can start with the first option now. So it is given to us that the urea solution is 6% weight by weight. So if we have 100 gram of solution, so in 100 gram of solution, we have 6 grams of urea. So the moles of urea is going to be equal to 6 by 60. So these many moles of urea are present in 94 grams of the solvent. So 94 grams we had found out by 100 minus 6. And this has to be multiplied by 1000 as the molality is equal to the number of moles of solute present in 1 kg of solvent. So for the first option, the molality will come out to be equal to this. So this is approximately equal to 1 point something. Okay. If you look at the second solution now, we have 5.85 weight by weight percent NaCl solution. So similarly, as we're done in the first option, we have 5.85, these many grams present in 100 grams of the solution, divided by the molar mass, 58.5. This will give us the moles. If you talk about the mass of the solvent, that will be equal to 100 minus 5.85, which is 94.15. And it has to be multiplied by 1000 to convert the grams into the kilogram. So this will approximately give us a value equal to 1000 divided by 941.5. But this is NaCl solution. So for NaCl solution, the I value is equal to 2. So the effective value of I into M will be a little greater than 2. So 2 point something. That something is not relevant in this case because we have to give a qualitative estimation. Okay. If you look at the third option now, we have 1.8% weight by weight of glucose. So for the third option, we have 1.8, which is the grams of glucose upon the molar mass, which is 180, upon 98.2 grams of the solvent into 100. So this value is approximately equal to 0.1. And if you talk about the fourth option, the molality has been directly given to us. The I value will come out to be equal to 4. So this is effectively 0.4 molar in the solute. So if you talk about the greatest freezing point and the boiling point now, so greater the value of the molality of the solute, greater will be the elevation in boiling point. So if we talk about the solution which has the greatest molality, we can clearly see that the second solution has the greatest molality. So the boiling point T4 shall be the greatest among all of these. And if we talk about the freezing point now, so there is a depression in the freezing point due to presence of solute. If we have to find out the solution which has the greatest freezing point, it means that the solution must have the least amount of solute present in the solution. So we can clearly see that the least molality is of the third solution, which is 1.8 weight by weight percent glucose solution. So depression in freezing point will be the least in this case, and the freezing point will come out to be the greatest. So the freezing point of the third solution will be the greatest. So if you look at the options which are given to us, we have to report the greatest freezing and the boiling point. So the greatest freezing point is T5, whereas the greatest boiling point is T4. So for this question, we have to select the correct answer is option C. Let us look at the next question now. Question number 23. P and Q are volatile liquids that form an ideal solution. The PP0 and PQ0 are 300 torr and 600 torr at temperature T. Starting with vapors of P and Q, it is given to us that the mole fraction of P is 0.4. The pressure is increased isothermally such that the liquid starts to form. Now pressure is further increased such that all of the vapor is converted into liquid. We have to comment on the mole fraction of the last drop and the first drop. Okay. So if we talk about the information given to us, in the initial stage, we had only vapors. So we can probably show the gaseous molecules. So in the gaseous molecules, the mole fraction of P is 0.4. So we can use Yp equal to 0.4, which means that the Yq, mole fraction of Q in the vapor phase, shall be equal to 0.6. Now it is mentioned to us that the pressure is increased such that the liquid starts to form. So when the first drop of liquid is formed, students, the mole fraction in the vapor phase is going to be this. Okay. So we can have the Raoult's law and the Dalton's law. So we'll have Yp into Pt is equal to Pp0 into Xp. So we are interested in the value of the Xp. Similarly, we have Yq into Pt is equal to Pq0 into X of Q. We can directly divide this expression. So we're going to have Yp by Yq is equal to Pp0 into Xp upon Pq0. There will be a naught here as well, upon Xq. Okay. So we can put these values. We have Yp is equal to 0.4 and Yq is equal to 0.6. So this will come out to be equal to 4 by 6. The value of Pp0 and Pq0 are 300 and 600 respectively. So this will be 1 by 2 into X of P by X of Q. Okay. So this on simplification will give us a value of Xp by Xq equal to 4 by 3, which must mean that the mole fraction of P is equal to 4 upon 7, whereas the mole fraction of Q is equal to 3 upon 7. Okay. So we can clearly see that this is given in the B option. We can now check for the other data which is asked in the question about the last drop. So now if we talk about the last drop, students. So in the last drop, we can see that whatever the vapors were present initially are now all converted into the liquid phase. So effectively, we can now have the mole fraction of P in the liquid phase is equal to 0.4, whereas the mole fraction of Q in the liquid phase will be equal to 0.6. So we had already seen that all of these vapors will be converted into liquids. Okay. Now the examiner is interested in the value of the mole fraction of the last drop. So that is Yp and Yq. So we have to find out Yp by Yq. Similarly, as we had done before. So this will be equal to Pp naught into Xp upon PQ naught into XQ. So this will be equal to 1 upon 2 into 4 upon 6. So this is equal to 1 by 3. So now we can say that the mole fraction of P in the last drop, which is Yp, it will be equal to 1 upon 4, whereas the mole fraction of Q in the last drop will be equal to 3 upon 4. So we had already seen that only one of the options were matching. So the B option is correct, and we have to mark the option B as the correct answer to question number 23. Let's look at the next question now. Question number 24. Two volatile liquids X and Y that have their respective vapor pressures as 100 torr and 120 torr in pure form at the temperature T is mixed. In solution, mole fraction of X is 0.7. The total vapor pressure of this solution at temperature T is found to be 110 torr. Select the correct statements about the solution. So the examiner seems to be interested in the type of deviation shown by the solution. So if we talk about the vapor pressure, if the solution were ideal, we can calculate that pressure using the Raoult's law. So we'll have P Raoult denoted by PR equal to 100 into 0.7 plus 120 into 0.3. So this will be equal to 70 plus 36, which is equal to 106. So if the solution were ideal, it would have exerted a pressure of 106 torr, but in reality the solution exerts a pressure equal to 110 torr, which means that the solution shows positive deviation from Raoult's law. Okay, so if you look at the options which are given to us, option A is correct. Delta H mixing is positive, delta V mixing is also positive, so option B is also correct. Option C will be automatically incorrect if option A is correct. And if you look at the statement D which is given to us now, the given solution which has a mole fraction of Y equal to 0.3 act as a minimum boiling azeotrope at this composition. So this is incorrect, students. At this composition, the vapor pressure exerted is 110 torr, but if the solution has to be a minimum boiling azeotrope, it must have vapor pressure greater than both the individual vapor pressures. So the solution would have been a minimum boiling azeotrope if the pressure were greater than 120 torr. So the statement D is also incorrect. So if you look at the options which have to be marked for this question, we can clearly see that the correct answer to question number 24 have to be marked as option A and option B. Let us look at the next section now.